Support for Lab Out Loud is provided by NSTA, the National Science Teaching Association. Find out more about what NSTA has to offer at nsta.org. This episode of Lab Out Loud is sponsored by the 3M Young Scientist Challenge. The 3M Young Scientists Challenge invites students in grades 5 through 8 to compete for an exclusive mentorship with a 3M scientist and a $25,000 grand prize. Enter at youngscientistlab.com until April 26th. Start today. You're listening to Lab Out Loud, Science for the Classroom and Beyond. And today our guest is helping us understand the differences of students giving an incorrect answer or an answer that is rooted in an alternative conception.
I think there's a difference in between only incorrect answers or if it's really a misconception or an alternative conception underlying it. There may also be a difference between a domain-specific concept and cognitive biases like this anthropomorphic teleological conception. For example, just when students are asked to talk about enzymes and they say, okay, the substrate wants to go to the enzyme, or they speak about an active movement of molecules in the context of chemistry.
That's up next on Lab Out Loud, but first I'm your co-host Dale Basler.
And I'm Brian Bartel.
And we have a long-distance guest today, coming all the way from Germany.
My name is Tim Hartelt. I'm working at a German university, the University of Kassel, in the Department of Biology Education. And I'm currently working on my doctoral dissertation. In my research, I'm investigating how we can help students to acquire an appropriate understanding of evolution. And I investigate which specific learning activities can be helpful for students to learn about evolution, in particular natural selection. And I'm also interested in how teachers teach the topic of evolution, how they diagnose and deal with alternative student conceptions, unscientific conceptions of evolution.
Can I ask a little bit about your job here? We are not terribly familiar with having a department of biological evolution. A biological science teaching, for instance, or biological education, as you mentioned. We often would have a generic science education department in many of our universities, but you have a very kind of like a honed-in specialty there, is what you're saying.
Yeah, we have different departments for different science subjects, for example, chemistry education and physics education. And most of the teachers are also teachers for biology and not for chemistry or physics. So most teachers have two subjects. So maybe it's biology and chemistry, or it's not. My second subject I studied at the university was history. And yeah, sometimes you teach in school also other science subjects. But we have these different departments for biology education, chemistry education, physics education.
And your university is where?
In Kassel.
Kassel, okay.
Not a very familiar town, I think, for people outside of Germany.
Mm-hmm. So in the United States, I think most of our educators could probably pinpoint Germany. Where in Germany are you located then? I guess geographically, a north, south, east, west, kind of a helpful there?
Pretty much in the middle of Germany.
Right in the middle, okay.
Yeah, I'm cheating. I'm looking on Google Maps right now. You are kind of smack dab. It's like, if you look on Google Maps where it says Germany, you're very close to the word right through the middle of the country, Germany.
I never tried to locate Germany as a whole in Google Maps, so maybe I have to do it myself.
You're between Hanover and Frankfurt.
Oh, okay.
Kind of. It kind of looks like it's like right in between, in line there.
And tomorrow on Geography Out Loud.
Well, I just realized I'm telling someone in Germany where they are.
Well, we noticed that you had an article that came out recently, and this was titled Teachers' Ability to Diagnose and Deal with Alternative Student Conceptions of Evolution. Now, that caught our eye because, of course, we like to talk about science education, and in particular, this is a biological education piece here. So can you tell us a little bit about the study and I guess just set the stage for us, please?
Yes. In this study, we investigated how teachers can diagnose and deal with student conceptions about evolution and which factors are connected to these abilities. So we did a questionnaire study with nearly 200 participants, pre-service teachers, in-service teachers, and teachers in practical training. And in the study, we confronted them with alternative student conceptions of evolution and asked whether they agreed or disagreed with the statements of the students, and also if they disagreed with the statement, on what conception the statement is based on. And we then asked them how well they would do with the incorrect conception of the student, how would they react if they were in class. We furthermore asked the teachers to report their acceptance of evolution, and we measured their understanding of evolution. And then in the statistical analysis, we investigated what ways of dealing with student conceptions of evolution teachers report, how they suggest to deal with these conceptions, how the ability to deal and diagnose student conceptions change with professional experience, how it's connected to their understanding of the topic and also to their acceptance of evolution.
How did this study come to be? Like, what put this in your field of view to study this question?
Yeah, I realized as a teacher how many alternative conceptions students have, not only in evolution, but especially in the topic of evolution, and how resistant they are. So I taught the topic of evolution to students of, I think, 14 years old, around 14 years, and I thought I did it very good. But at the end of the term, most of the students still had many alternative conceptions about evolution. So I started to think about how can we make evolution education better? What specific learning materials can students help to gain a scientific understanding of the topic? And I think what's also important is to not only investigate how to help students learn the topic with rich learning materials and how they can change their conceptions, but also to investigate how teachers currently teach the topic of evolution, how they try to help their students get a better understanding of evolution, how they diagnose specific alternative conceptions, and how they deal with these conceptions in order to bring this research together and develop new learning materials to prepare teachers to teach the topic of evolution.
As I think back to teaching biology myself, there were times, especially in evolution, but in other areas, where I would teach something and I do know the content. And when I went through an assessment, you look at the results and you shake your head and think, did I just not teach that well? Did I lead them astray somehow in how I taught that? And I think that's what you're getting at there, is that there could be a quality of the materials or how those materials are presented during instruction that can affect student understanding. But you're also saying that it can go deeper as well, because we might have teachers that don't understand themselves.
Yeah, that's definitely one aspect. What we found out is that teachers who don't understand the topic of evolution themselves very good, that they have more problems in helping students to acquire an understanding of evolution, I think that's also very, very obvious that there's a connection. There are many studies, and also our studies showed that not every teacher has a good and deep understanding of evolution. And I think it's necessary, and that's what our study showed, that that's necessary to understand the topic of evolution, to maybe know common alternative conceptions of evolution of the students, what learning problems they have, to be able to diagnose these conceptions and be able to deal with them. But yeah, also I think you can do the best lessons or try your best, and students will still have alternative conceptions after evolution education. There are a lot of studies who show that even after good instruction, students still have alternative conceptions. They also have scientific conceptions after that, but they sometimes coexist with these alternative conceptions. So just to give an example, students maybe say that cheetahs mutated in order to become faster, and cheetahs who were faster had more offspring. So there are some concepts that are scientifically correct. There is a concept of mutation and of differential survival or reproduction, but they often mix this newly acquired knowledge with alternative conceptions, that they think that evolution is goal-directed, that species evolve to fulfill a need, a goal, so they mutate in order to be faster. And I think that's can be a big obstacle, these alternative everyday life conceptions that students have. So teachers should address these conceptions when they talk about evolution, and not only teach the scientific concepts, but also talk with students about their own conceptions, their own preconceptions, because some studies have shown that learning the scientific concepts without taking student conceptions into account does not lead to a replacement of the alternative conceptions, but more to a coexistence of scientific and alternative conceptions.
I think about when, again, you would go through your formal coursework to become a science educator, and I'm talking about the actual content area. You hopefully those teachers will be grounded in a good knowledge base of what evolution is and what it isn't. But again, if you're talking about a survey course, talking about all of biology, I didn't have a deep understanding of anatomy, but I did much better with molecular biology and evolutionary biology. That's one thing, and that might be the standard science coursework that you'd have in university. But this really says we need to do a better job in our education instruction, and it's not just making sure you know the content, but you know how students learn, and then being able to probe them and check for their understanding, and then correct them along the way as you do that. And obviously that's an art form there. That's a profession that constantly requires development that takes time to mature, and we're going to see that, I guess, more formal educators that have a few years under their belt are going to have that experience and know where students may trip and fail, and how to pick them up and how to keep moving forward.
Yeah, definitely. I think there's two sides. You have to know the content, but you also have to know how to bring that content to the students, and to have this pedagogical content knowledge. One thing that can help to know how to teach is professional experience, to be in the classroom and see what works and what don't works, and try different things. But I think the university courses, teacher training can also help to get teachers better prepared on how to teach the content to students.
I think we've all had those moments where you're talking to a colleague or even a friend, and you're saying something and you kind of have that moment where you say, well, you know what I mean, kind of thing. So you may misspeak, but both professionals know what you mean. So you can use like anthropomorphized kind of terms and stuff like that, because you know that the true answer is there ahead of time, but
you hope they know the true answers.
Well, I mean, if you're and so you're thinking on that common wavelength, so then you kind of cheat and use those kinds of terms, but we have to remember that our students don't know that, so they're brand new to that, so we don't want to kind of use our casual language, I guess, with students, and be on guard for that, to be careful with that.
Yeah, definitely. I have these moments very often where I think, okay, no, I have to stop here and go back and explain it in another way, not in an anthropomorphic or teleological way. And I think maybe that's what we can try to help students to get aware of language, to get aware of these conceptions, because in everyday life we explain so much goal-directed. So I go to the kitchen in order to get a cold drink. That's a goal-directed explanation, and that's totally acceptable. And then you are in the biology classroom, or even in a chemistry classroom, in a science classroom in general, and then this type of explanation is not acceptable anymore. But students and also teachers often slip into that language, sometimes just to make it short, the explanation, because whole explanation based on natural selection is a little bit more complex. So maybe say it in a teleological way. And I think you can't prohibit teleological language in the science classroom. It won't be successful. But I think what we can try is make students aware of their conceptions, making them aware that they have these conceptions, teleological, anthropomorphic conceptions, etc., and to help them identify it in their own explanations. And maybe that they do the same thing as we and say something and then notice, oh, okay, but now I'm in the classroom trying to explain evolution to another student who maybe does not have a good understanding of the topic, but I have, so that the other student doesn't think that evolution is goal-directed. I can't use the teleological explanation. I have to I have to give a bigger explanation, go more into depth, and explain it with the concepts of natural selection.
Mm-hmm. Brian, quiz time.
Oh boy,
are you ready? I nicked one of these questions from your paper, Tim. Okay, it's you're the biology teacher, so I can get this wrong. I'm okay, but
sure.
Pressure's on. Whales evolved from land-living mammals. It's got this nice setup here. The origins of the transformation from land animal to sea creature may be observed among some wild sheep who have lived on the coast for hundreds of years. These sheep like to eat seaweed and kelp so much that they are often observed swimming in the water to eat it. If we returned millions of years later to observe these animals, what might you see? A. Sheep who wanted to be better swimmers and so developed the ability to swim greater distances to eat kelp. B. Two distinct related sheep like organisms, one that lives in the water and eats kelp, and others that live on land and eat plants. C, these sheep will become extinct because they will not be able to find other food and only their fossils will remain. D, this is the last one. There are so many possible outcomes that there is really no way to predict what will be seen.
Well, I want to eliminate A automatically because
it says
sheep want
there's your goal oriented. Sheep wanted to be better swimmers. You can just see them. Oh, they're putting on their swim caps, the little holes for the horns.
And as sheep, they want to do what other sheep are doing. So there's no. So I can eliminate A.
Two distinct but related sheep-like organisms. One that lives in the water and eats kelp. The other lives on land and eats plants. That's B. C, these sheep will become extinct because they will not be able to find other food and only their fossils will remain. And B, there are so many possible outcomes that there really isn't a way to predict what will be seen.
I want to go with D.
Tim, do you want to give him do you know the answer, Tim?
That's a good answer, D, because evolution is not predictable in that way, and this big time frames we are talking about when I think answer B was distinct species, so that's a big time over that
one or the other kind of a scenario that's too idealistic.
Yes.
What about C? Because I suspected that each one of these responses is rooted in a misconception. So A is the sheep wanted something, so that's a goal-driven thing. 2 is like we have two distinct, like we go this way and that way, so that's
a direction.
That's a direction. C, these sheep will become extinct because they will not be able to find other food, only their fossils will remain. Now, I feel like that's so that can't
you can't predict that, and you can't predict what other pieces are in the environment.
Yeah, correctly. That's the conception that evolution would be predictable, and all the other factors.
It
Listeners
does say,
can't
though,
see
it
me,
says,
but I'm wiping the sweat off my forehead here because I didn't expect a quiz this early in the morning.
That is not fair because I would flunk. Because I'm sitting here reading now. If we return millions of years later to observe these animals, this is what a high school student would say. What might you see? Isn't the kid going to come up to you and say, well, we might see sheep extinct and their fossils remain? But if you approach this with what is the most correct, D still comes out of there. So yes. They may go extinct. That is a possibility. But
yes, absolutely.
But saying that with that kind of certainty is the incorrect part, right?
Yeah.
After the break, we'll be right back. Each year, the 3M Young Scientist Challenge recognizes a grand prize winner, 10 finalists, the Improving Lives Award winner, and up to 50 state merit winners nationwide who have demonstrated a passion for solving everyday problems to improve the world around them. To enter, students in grades 5 through 8 will share an original idea that helps solve an everyday problem in their community. They are invited to submit their solution in the form of a 1 to 2 minute video explaining the science behind it. It only takes an idea and a 1 to 2 minute video to get started. Learn more and enter at youngscientistlab.com. And now, back to the show.
How did you develop these misconceptions, or where did you find some of this from personal experience, or is there a list of misconceptions somewhere that we should all be checking into?
Yeah, there are lists. There are so many studies which investigated students' conceptions, especially student conceptions of evolution. And so I based my study on that. The questionnaire on understanding of evolution. This was one example of 7 different questions, and other questions and answers included different misconceptions, goal-directed conceptions, anthropomorphic conceptions, or essentialist conceptions without acknowledging variation, etc. I took these questions from other studies, and when we confronted teachers with alternative student conceptions and asked them if they are correct, these explanations, and how they would deal with them, we also used authentic student explanations from other studies. So when in an interview study, a student said something and that was a common alternative conception, we used it and took it in a hypothetical teaching scenario, and then presented it to the teachers in order to have a most authentic situation that you can create in a questionnaire.
Would these be good questions to also use with students? You use these with teachers, right?
Yes, correctly. But I did this with students and used some of these questions, maybe some easier questions I used at the school, but in the same format, asked them what is the correct answer here, and then had an open discussion about it in class. Or firstly, they should only discuss it with their partner and then with the whole class, argue why one answer is correct and one is not. For example, say, okay, answer A is not correct because there's the word wanted, and that sounds like the species want something, and because of their will, they can willfully change. Then argue, okay, what's with the other questions? Which answer is correct? Which answer is based on, for example, the concept of natural selection? I think that can help both as an assessment at the end, but also at the beginning of the next lesson, after you taught that topic the first time, and then, okay, look, what conceptions do the students have? Maybe you can ask the questions at the beginning too, so they answer the questions at the beginning and then at the end, and see, okay, what has changed in my own conceptions. I think you can use these questions. You can also use spontaneous student explanations in class and pause the class and say, okay, what do the other students say to that? Do you agree with that explanation? I think that can help to talk about it, really to talk about in depth about the language, about the conceptions, and even if it's only just a keyword, a signal word like wanted, just to discuss it in class and to make students become aware.
And I think I would often steer into some of those misconceptions if I knew that they existed. And I think, that's a sign of a good teacher, because I think about that with reading and with math. Some of the common pitfalls that students might make. Some of this comes with experience, and some of it comes with better preparation or better resources. But, the giraffe's necks would be an example of that, talking about how we got it wrong in the past and where someone might think that this would, the Lamarckian view of evolution, that giraffe stretching its neck as a goal to get taller, for instance. And when you discuss that tends to help students realize where it can go wrong and why it's wrong, and where they may also fall off the path as well if they're not careful.
Yeah, exactly.
There are a lot of resources for misconceptions. I think this is a big area. And all right, so I'm going to give you a question, Dale. Where do you think one of the most common misconceptions is in physics or astronomy? I'll give you that. That's a cheap one.
Ooh, common misconceptions in physics. Well,
I'm gonna lead you into astronomy here.
Well, I was going to do physics. One of the common ones in physics is the idea that the heavier thing will fall faster. Like still,
Sure.
and it's one of those things that's so simple. You can just go take two things and drop them, which I would do in class: a bowling ball and another ball.
Right.
And they, for some reason, that is just in our head. So
yeah.
Did you
the
have
misconception
something?
becomes the opportunity to learn.
Oh, for sure. Did you? And I've done it with teachers too. I had elementary pre-service teachers that I did a class for, and we went out and got a 14-foot ladder outside and just dropped it, and just right there before their very own eyes. You kind of ask that question ahead of time, get them to commit to it, and then kind of go there. And it's kind of funny. People just don't drop the objects very often.
Yeah. What about astronomy?
I never really taught a lot of astronomy, but a misconception in astronomy?
Specifically the night sky.
Specifically, I feel like you're fishing for something specific. You have something in mind?
The phases of the moon. That one comes up a lot.
Oh, yeah. Well, I don't know if that's a misconception as opposed to just straight up not understanding how it works. Aren't those different? Like the phases of the moon, one of the responses to the phases of the moon, people will say clouds.
Oh.
And
well, I'm thinking in the sense that students will develop their own idea or their own constructs of their mental models of what's happening. And could those be considered misconceptions in this case?
Tim, what do you want to weigh in on this?
I know we're veering off of biological.
But if you
content.
So what is the difference between a misconception and just not knowing? Because I would lean towards the incorrect answers about moon phases from students is just them guessing, not saying. Whereas I think a misconception is them confidently giving the wrong answer.
Yeah, I think there's a difference in between only incorrect answers, for example, just counting wrong in math, or if it's really a misconception or an alternative conception underlying it. There may also be a difference between a domain-specific conception, which is only in the specific domain a problem, and cognitive biases like this anthropomorphic teleological conceptions, which are not only common in evolution education, but also in other topics when students are asked to talk about enzymes and they say, okay, the substrate wants to go to the enzyme, or they speak about an active movement of molecules in the context of diffusion chemistry. I think there's a difference between these cognitive biases, which are underlying many student conceptions in different contexts, and these domain-specific conceptions, and are just incorrect answers.
I did some Googling. I did some searching for, I think I did swimming sheep evolved. I'm looking for news stories that kind of would come up and be sort of fall victim to this. And the article that's in front of me right now, animals that adapted to defend themselves against people. And later down there they have like evolution would generally tip the scales towards large horns, since bigger animals are better for a male wanting to fight, defend itself, and show off to all the single ladies. Now, I searched for wanting in the article, kind of seeing for those kind of watchwords. And like in that sentence, it's kind of correct. Like evolution tipped the scale. Like they're saying evolution went towards longhorns but males wanting to fight is the victim. I think this could be a lesson here that you could have an assignment for your students, like throughout the year. They if they find an article, a news story, or something like that uses this kind of language, that they would catch it, identify it, and then correct it. That could be a project for them.
Yeah, definitely. Also, I encountered so many newspaper articles about the corona pandemic and
Ah,
about coronavirus, where it said the virus wants to mutate or needs to mutate in order to survive. Um,
sure.
so um, and when I talk with people, sometimes they come up with that themselves. When I explain that to them, what I'm doing, what I'm researching, and what some of the learning problems of students are in the context of evolution, they say, "Yeah, but I'm reading that in the news too." These experiments. Um, yeah, I think it would be a good task for students just to scan some newspaper articles and look after this language and maybe to correct the writing and write it more scientifically.
Yeah. What about human evolution? I think I saw some questions or a survey about human evolution. Were there so many interesting findings on misconceptions regarding human evolution?
Yeah, human evolution is also a very interesting topic because there's also a difference in the acceptance of human evolution and micro and macro evolution. When we talk about natural selection and how one species changes over time, more people tend to accept that um, than human evolution. There are more people who reject that humans and monkeys have a common ancestor. Often misconceptions also, which leads to a rejection of evolution, too, that humans developed from chimpanzees and
Hmm.
people see that they just share a common ancestor. Yeah, because of that, this topic is, I think, not so easy to taught, especially when you have students who are more religious and have this perceived conflict, which in fact does not necessarily exist, but this perceived conflict between evolution, especially human evolution, and their religious beliefs or worldview.
Sure. Well, it gets really personal because we are humans, and I could imagine students saying, "Well, wait a minute, we are goal-oriented." I mean, there are people, that we use evolve not in a scientific way. So we say like you need to evolve your thinking and things like that. So I saw one of the survey questions you have is humans do not evolve; they can only change their behavior, and then you have ranking that on a Likert scale, strongly disagree to strongly agree. I could see that is in biology class is sort of a always kind of it's personal, right?
Yeah, definitely. But I think we can also help students to don't take it so personal. Maybe especially when they have this conflict with their religion or worldview, just to talk with them about that they can both believe in God and accept evolution. That there is not necessarily a conflict between the two. There are many scientists who are religious. There are many religious leaders who accept evolution, especially if you don't take every word in the Bible literally. You can believe in God and be religious, but also know that evolution is a fact and also humans evolved. For example, taking a role model, a guest visitor, for example, into the class who is a scientist, but also accepts evolution and can talk and discuss with the students how to combine maybe these two aspects.
Mm-hmm.
So Tim, before we let you go, I think addressing the problems is definitely one step in the right direction. We know some of the answer is simply time. More experience is going to help teachers understand their content better, as well as know what their students might be thinking in the class and being able to address that. What might be some other answers in combating student misconceptions?
I think what you said are two very important factors, helping teachers to understand the topic better, maybe to first be aware of their own conceptions. I think I have alternative conceptions myself, not maybe in evolution, but in other topics, and especially when we're talking about physics or so. Maybe use that as a starting point, your own conceptions, which with you started university, thinking about how to deal with them, get familiar with different student conceptions so that you can more easily recognize them in classes. Talk with colleagues how they deal with student conceptions. I had recently a mail from a teacher who read the article and said, "Oh, that's so interesting. Now I will talk to my colleagues. I have this and this ways of dealing with student conceptions, but I'm not so sure. I will talk with other biology teachers at my school and just talk about it, find ways, exchange ideas, how to deal with alternative student conceptions." So I think that are some aspects what maybe can help, and also teachers have to get good learning materials that they are prepared for teaching evolution. Learning materials they can use, learning materials that not only focus on scientific conceptions but also take the students' conceptions into account, especially when teachers are not so sure about if they can teach it, and some teachers say, okay, then I teach it in less hours because I'm not too sure in that topic too. But if they have good learning materials they can use in class that help students, they maybe feel better prepared. And I think research can help with that. I'm currently doing a study where we use different learning materials, specific learning materials, and investigate which learning materials and which factors help students to get a better understanding of the topic evolution and how to reduce their alternative conceptions. Teachers need to get these materials that they can use it in the class, because they can't do everything on their own. And I think the teacher should get that help.
Tim, I like how you also, you just acknowledged that you have your own misconceptions, and I think that is a key thing that popped in my head as you were speaking, is that we have to maybe spend some more time defining misconceptions and allowing students to understand that we all have them, and that maybe makes these conversations a little bit more disarming, because nobody, especially students, but nobody wants to feel like they're wrong. They don't want to feel stupid or anything like that because they get something wrong, and a lot of times that'll cause a student to withdraw from the conversation. But if we can introduce the idea of misconceptions up front and talk about how they that they originate for different reasons, and make that distinction from being just straight up wrong, that would kind of invite that conversation and allow them not to maybe turn away from it.
Yeah, I think that's a good idea and a good way to go. Because of that, I also try to avoid the word misconception because it's very negative and more, say, an alternative conception or a preconception.
You have that language in the article.
Okay, so preconception I've heard, or alternative conception. Hey, that makes sense because you're right. A mistake has got it right. Yeah, you're right. That makes good sense.
Well, Tim, thank you so much for your time. It's been a wonderful conversation and a good personal reflection on ourselves to think about how we might teach something and where our own biases and alternative conceptions factor into our own education and our own instruction.
Yeah, thank you very much too. Thank you for having me.
Thanks much. This was great. Thanks for listening to this episode of Lab Out Loud. If you'd like to learn more about some of the things discussed in this episode or previous episodes, you can find show notes at our website, laboutloud.com. If you have a guest idea or a future topic that you'd like to see on Lab Out Loud, go to our contact page and send us a message. Also, you can subscribe to Lab Out Loud on your favorite podcasting app, such as Apple Podcasts, Spotify, Google Podcasts, Stitcher, or wherever you like to find podcasts. While you're there, leave us a review and rating. Your input helps others find our show. Thanks again for listening.